Algebra 2 Regent state sample questions. Question number 2. Functions f, g, and h are given below. F of x equals sine 2x, g of x equals f of x plus 1, and h of x is this given graph. And which statement is true about functions f, g, and h? A couple of them are odd, one's even, a couple even, one odd, neither even. So this is really, obviously, it's an odd, even, neither function question. And so this is all about that type. Now, states kind of hinted that they like these types of questions a few times where they want you to compare different types of functions differently. Like here they're giving us functions in equations, here they're giving us a function as a transformation, and here they're giving us a function as a graph. And we need to be able to compare these three together. Um, when it comes to odd, even, and neither functions, graphically is really the best way to think about all of them. So I really want to think about what these all look like graphically. But first, a quick review of what odd and even functions look like. So an even function, and remember this is different than even degree. Even degree simply means that it ends in the same direction. Like it's both ending up or it's both ending down, something like that. An odd degree means, one arrow's up, one arrow's down kind of thing. That's different than functions. So an even function versus an odd function. Now, an even function does need to be even degree, meaning the arrows have to end in the same direction. But an even function has what we call y-axis symmetry. Those are the ones that look like a mirror image over the y-axis. Um, something that's a terrible picture. Something like h of x. Is what I'm trying to draw here. So y-axis symmetry is, we see it's a reflection across the y-axis, something like that. An odd function is what we refer to as point or origin symmetry. And that's one where you can think of it as a rotation around the origin. So we could also think of even function as a reflection across the y-axis. Origin symmetry we want to think of as a rotation, a 180 rotation about the origin. And so that, again, for it to be an odd function, it has to be odd degree, meaning the arrows have to be pointing, in different directions, something like that. Again, that's a pretty sloppy picture, but when I flip it upside down, it looks exactly the same. That's what odd symmetry needs to look like. So even function, odd function, and neither is when it's neither. Now, this first example, h, or the third one, but h of x, we see this clearly has symmetry across the y-axis, so this h of x is definitely an even function. Even function. So h of x is even. So that rules that out. That rules that out. So now we just got to determine about the function sine 2x and f of x plus 1. And I want to take a look at what these things look like graphically. So I'm going to use my graphing calculator. And I want to take a look at sine 2x, close parentheses. And then I need to do zoom trig, zoom 7. Gives me a sine graph. Now, sine doesn't have arrows. So when I say like the arrows pointing in the same direction, the arrows pointing in the opposite direction, it doesn't necessarily have to have arrows. But if we take a look at this sine function here, um, and kind of really zoom into it, one thing you'll notice is that it's definitely not y-axis symmetrical. I can't reflect across this line. It's not going to happen there. But it is origin symmetry. Like if I take this graph and let's say I clone it and flip it upside down and then compare these two side by side, you see how they are exactly the same. And so sine is an odd function. The sine function is an odd function. So let me use red there. Let's draw a little sketch here. So f of x equals sine 2x. The 2 in there just has to do with the frequency of two waves, but really that's not even relevant here. So it looks like this. There's your sine function, and this is an odd function. And so f of x is odd. So that's still alive, that's still alive. So it really comes down to g of x. Is g of x also odd, even, or neither? And g of x, what they're saying for g of x is that it is equal to f of x, the sine 2x, with a plus 1 on the end. And this has to do with our transformations. Remember, there's a difference between f of x plus 1 and f of x plus 1. The inside, this is your side-to-side transformation. And remember, plus inside means left, minus would mean right. And the outside plus 1 or plus or minus 1 or any number is your up down. And the plus 1 here means up 1. So what they're saying is that we're going to take the sine 2x and move it up 1. That's what g of x is. So that would be this graph shifted up 1. So the sine function is an odd function. Let me write this down again. Sine of x is odd. Cosine function is even. But these are the basic functions, and if you change the amplitude or the frequency, that's not really going to change anything about sine and cosine being odd and even functions. The thing that would prevent these from being odd and even functions is transformations, translation specifically, of moving it up, down, left, and right, so on, so on. Because here's my sine x graph, and if I take this and then add 1 to it, plus 1, take a look at the graph, I'm going to see the whole graph was moved up 1 from its original location. And the problem here is it's still obviously not an even function, but if I clone it again, flip it upside down, it looks similar, except this one's above the x-axis, this one's below the x-axis, so it's not the same. So sine in its basic form is odd, and cosine in its basic form is even. But if you move them up and down or side to side, that can change things. Moving them side to side can change from odd to even, or it could just make it neither. But moving them up and down will definitely make them into neither functions. So this is a neither. And so that is why our answer is 3. That f of x is odd, the basic sine 2x is an odd function because it's the same flipped upside down. The g of x, which is sine 2x with a plus 1 attached, which moved it up 1, and that's what made it no longer symmetrical about the origin. So that was a neither. And then the h of x, the graph here, is even because it is a mirror image of itself across the y-axis here. I see a mirror image. It's a reflection across the y-axis. So I think you're very likely to see a question like this on the Regents. Maybe not this exact format, but with this information, knowing that an even function is y-axis symmetry, an odd function is rotation 180 through the origin symmetry, and then of course neither is neither. But I think it's important to really know that sine is an odd function and cosine is an even function, unless it's translated up, down, left, right, stuff like that. That's where things change. Affecting the amplitude, like 2x, or affecting the, oh, that's not amplitude, the period, the, I'm sorry, the frequency, that doesn't, it's still an odd. If it had an amplitude, like say it was 3 sine 2x, it would still be odd. It's only the translations that'll change it from odd to neither and things like that. So make sure you know the difference between an odd function and even function, and sometimes neither. See ya.